All right. We've talked about the anatomy of the heart and parts of the circulatory system. Now let's get to the good stuff, the physiology, the functioning of those systems. We introduced a couple of key terms already. When we talk about the time when the heart is actually contracting and pumping, that is called systole. And between beats, when the heart muscle is relaxing, that period is called diastole. And so we're going to come back to those terms later when we learn about blood pressure and systolic and diastolic blood pressures. But as we talk about the functioning of the heart, important to remember those two terms. When we're talking about the period when the heart muscle is actually contracting, that's systole. Between beats, when the heart muscle is relaxing, that's diastole. So, how does the heart work? Well, we describe the functioning of the heart and the coordination in the pumping of the different chambers of the heart in something called the cardiac cycle. And this diagram shows three parts of the cardiac cycle. And the video that's attached here, I encourage you to go back and take a look at that if you have about 4.5 minutes, because that's how long it is. It does a pretty good job, and it actually previews a little bit of what we might do when we dissect hearts in class. All right, so let's start at number 1 here, atrial and ventricular diastole. Don't we sound all medical? So, atrial and ventricular, atria and ventricles, diastole resting. So between heartbeats, what's happening? Well, the blood is returning to the heart while the heart muscle itself is relaxing. Blood coming back from the body, returning to the right atrium through the vena cava, inferior and superior vena cava, these big veins. And then veins from the lungs, pulmonary veins, are bringing oxygenated blood back from the lungs to the left atrium. As that's happening, the blood's filling those atria, and it will start to leak down into the ventricles. And during that time, the valves that are separating the ventricles from the big arteries that leave the heart are closed. So the heart is filling. Part 2, atrial systole. That is atrial, atrium, both of the two atria. Systole, contraction, both of those two parts of the heart are contracting, and the blood that had been filling them is squeezed down forcefully into the ventricles, completely filling the ventricles. And that sets the stage for the third part, ventricular systole. A fraction of a second after the blood is squeezed down into the ventricles, those ventricles will contract and push the blood out the arteries, opening up the semilunar valves that prevent the blood from flowing back into the heart from those arteries. And so ventricles contract, push the blood out into the arteries, and send it to the lungs or the body, either from the left or the right side. All right, the functioning of the valves is super important. And I ask you all to watch the video that's linked right here on the slideshow. If you didn't do that, I encourage you to do that right now. Super important to understand how these valves work. And if you have questions about it, I'm just going to, rather than show the video again that you've already seen, I'm going to ask you to bring those questions with me. We'll talk about it again when we actually get some hearts in our hands and we can look at those valves up close. There's a couple of videos linked here. I think it might be interesting as we pull out some stethoscopes and start listening to some heart sounds that you know what they are. So those of you who are interested might want to open up the slideshow and click on that short video to hear what are the thump-thump, thump-thump sounds when we hear a heartbeat through a stethoscope. All right, a lot of information on this slide. Sorry, bad slide technique. But this is explaining how the heart maintains its beat. The heart sort of beats on its own, but it's also under the influence of nerves and hormones. Stimulation from nerves or from hormones can cause the heart rate to speed up or slow down. But for a few seconds at least, you can pull a heart out of a body and it will keep beating on its own. It's able to generate a heartbeat on its own. And how that works is described on this slide and in the notes attached to this slide. I'm going to give you a heads up that I'm not going to ask you any detailed questions about this. The information is here for those people who are interested, and maybe someone wants to dig deeper into the functioning of the heart. That could be a personal learning project for you. And so I put some of that information here. But I will not assess you on the stuff that's on this slide. And if I change my mind, I'll let you know. So the next two slides talk about the structure of blood vessels. We have talked a little bit about this in class as well. And some of the videos that I've linked also have some discussion of the relationship between the structure and the function of the blood vessels. Three types, remember: artery, vein, and capillary. And for the smaller versions of arteries and veins, they get cute little names, diminutive names: arterioles and venules. Venules and arterioles are just small arteries and small veins. And the structure and the relationship between the structure and the function of these three different vessel types is something that you are expected to understand. And there is information on slide number 21 down in the notes and on slide number 22. And I think you can get that information from those. So I'm going to skip on to the part that I think I'm going to need to do a little explaining. And that is blood pressure. We've already learned when we did the experiment with baroreceptors and the baroreceptor reflex that blood pressure is super important measurement. Every time you go to a doctor, just about, they're going to throw a cuff on your arm and measure your blood pressure because it's that important a measurement. It gives us a window at how the heart and other parts of the circulatory system are functioning. And it could also alert a doctor or a medical professional to other issues outside of the circulatory system if our blood pressure is too high or too low. So really important measurement. And it's something that is super critical for homeostasis, because if we do not maintain an appropriate and sufficient blood pressure, things go bad. If the blood pressure is too low, then our tissues aren't getting enough and a rapid enough supply of oxygen and nutrients from the blood. And for organs like the heart and the brain, they do not tolerate that very well at all. Not good. And too high blood pressure is also bad. Super bad, because the arteries that are fashioned by evolution to be able to withstand high blood pressure are not totally indestructible. And when the blood pressure gets too high, it puts too much stress on the walls of the arteries, and damage can happen, and that damage can lead to blockages in arteries, and that can lead to heart attacks and strokes, and that can kill a person. So blood pressure and blood pressure homeostasis, super important. Reminder that we talked about systole and diastole. So we have systolic and diastolic pressures. The systolic pressure, the pressure measured in a blood vessel when the heart is contracting. So that's going to be when the pressure is highest. The heart has just pushed a volume of blood out into the arteries. So more blood, more pressure on the walls of the arteries. Diastolic pressure is the lowest pressure point, and that's when the heart is resting between beats and the blood is flowing on, mostly from the pressure that is caused by the elastic recoil of the vessels. So the heart beats, the vessels expand to accommodate the blood that's just been pushed out into them, and then they're very elastic. Those arteries will start to squeeze back and keep the blood moving along between heartbeats. All right, the last slide, and this is one that you may want to open up the slideshow because there are additional notes in that notes section below. But this is describing how we measure blood pressure with one of the coolest named instruments, a sphygmomanometer. Sphygmomanometers have been around for a long time, and they are still a critical piece of equipment for medical professionals. And a sphygmomanometer, if you are not familiar with them, is a cuff that is inflatable, connected to a little bulb that you can push air in there. And that cuff has a tube connecting to a pressure gauge so that you can measure the pressure inside the cuff continuously. And so the technician, the nurse, the doctor will wrap the blood pressure cuff around your upper arm, and the blood pressure inside the major artery in our upper arm, and that's the brachial artery, is actually the blood pressure that we typically measure. So as the cuff is pumped up and the valve to the cuff is closed, the pressure starts to increase on your arm, and you feel that squeeze. Eventually, the pressure is enough that the blood in the brachial artery is not able to pass through that pinched off artery underneath the cuff. And typically, the technician will pump the cuff up to anywhere between 150 and 180 millimeters of mercury in pressure. And then they will open slightly the valve that leads to the cuff, and the air will slowly start to escape. And then in the middle diagram, we see that there's a stethoscope that's placed on the person's arm just below the cuff. And initially, the technician will not hear anything in that stethoscope because that artery is pinched off completely. No blood is flowing past the cuff through that artery. But as the pressure drops, eventually the pressure in the vessel becomes equal or greater to the pressure squeezing the vessel, and blood will spurt through with each heartbeat. So with every contraction of the heart, a little blood will squirt through that pinched off vein. And that disrupted flow of blood, that squirting, spurting of blood, can be heard by the stethoscope. And that's what the technician is listening for when they have that stethoscope on your arm. As the pressure continues to drop in the cuff, the squirting starts to lessen as the blood starts to flow more smoothly through that vessel, through that artery. And eventually the pressure gets low enough so that even between heartbeats, there's no gap in the flow of blood through the vessel. It starts to just flow smoothly through the brachial artery. And at that point, the technician can't hear any more spurts of blood. And when those sounds disappear completely, the technician will note the pressure in the cuff at that point, and that is the pressure between heartbeats, the diastolic pressure. And then those two numbers are put together. The pressure at which the blood first starts to squirt through the pinched off artery, that's the systolic. And then the pressure when the blood starts to again flow smoothly through the artery as the pressure has dropped, that's the diastolic pressure.